What is the universe doing right now in this exact second? It is quietly shuffling heat, gas, and gravity into place. Here is the point in plain words: the quiet work prepares fireworks. Think of a city between parades, streets still hum with motion. Stars drift, clouds cool, and halos sip from cosmic rivers. This in-between is the long stretch between dramatic cosmic headlines. It matters because setup time decides the headlines that follow. Slow processes stockpile fuel, mix metals, and steady magnetic fields. Tiny nudges add up while nothing seems to change at all. A dark cloud might cool 10 million years, then ignite. A galaxy might gather wisps for a burst next epoch. Bottom line, the universe works hardest when it looks still. Streetlights of the Milky Way glow, but alleys hold secrets. Between stars sits the interstellar medium, thin gas and dust. You care because it sets the pace of star birth. Turbulence stirs the gas, shredding and clumping it like foam. Radiation heats surfaces, while shadows cool and thicken into sheets. Magnetic fields thread clouds, slowing collapse and guiding flows gently. Pressure makes phases, warm diffuse gas beside cold dense pockets. Energy leaks away through faint lines of carbon and oxygen. Then gravity wins small regions and they start to sink. Real numbers keep this grounded. Densities span 1 to thousands. Temperatures range from about 100 Kelvin to 8,000 Kelvin. A cloud can drift for 10 million years before collapsing. Only 1% of the mass becomes stars each round. Winds and newborn stars blow bubbles, fueling the next cycle. Shock fronts fold sheets, drawing filaments that feed infant clusters. Dust grains steal light, but also shield fragile molecules inside. Hydrogen pairs up on grains, making the gas easier to cool. Cooling deepens shadows, and gravity quietly sharpens its hold. Observatories map these rooms with radio lines of Co. They reveal hidden columns and trace where gravity gathers strength. Where lines brighten, clusters follow within a few million years. Where lines fade, gas drifts onward, awaiting another nudge. Net result, this quiet stew decides where stars can appear. That is why the alleys matter more than the boulevards. Step outside the galaxy and you meet a ghostly halo. That fog is the circumgalactic medium, a galaxy's extended atmosphere. Care about it because it controls whether galaxies starve. Filaments bring cool streams, slipping along dark matter scaffolds. Meanwhile, supernovae and black holes launch fountains back into space. Those fountains arc outward, slow down, and rain back gradually. Metals mix in transit, seasoning future stars with heavier elements. Cooling happens in patches, lighting faint ultraviolet and X-ray lines. Drag and gravity play tug-of-war, setting return timescales. A Milky Way halo likely stretches 300,000 light-years across. It may hold as much gas as the disk inside. Individual clouds carry 10,000 suns worth of material. Travel speeds sit around a few hundred kilometers per second. That means a single loop can take hundreds of millions. Quasar beams act like flashlights, probing these translucent corridors today. They show absorption fingerprints, revealing temperature, velocity, and composition. Simulations agree, showing recycling cycles that last several billion years. Galaxies with strong fountains keep fuel longer and avoid quenching. Galaxies that lose fountains cool less and stall their growth. Satellite galaxies also strip gas, feeding the halo with streams. Tidal tails unwind, seeding the halo with cold ribboned lanes. Those lanes often fall back, making lopsided star formation episodes. Bottom line, halos are the lungs that breathe galaxies alive. Between booms, they inhale, exhale, and quietly keep the rhythm. Now dive toward a calm galactic center, dim but restless. Most of the time, black holes feed in whisper mode. That means low accretion rates and feeble, flickering outputs. You should care because tiny drips still change galaxy weather. Gas spirals inward, stirred by magnetic turbulence called MRI. Friction heats the flow, then some heat simply escapes outward. Some gas misses the mouth and leaves as a breeze. Occasional clumps fall fast and the core flashes briefly. Jets may sputter on then off, sculpting bubbles in halos. Duty cycles are stingy, with bright phases just 1%. Sagittarius A nibbles extremely slowly in our own galaxy. Think a moon's mass every several thousand patient years. Even so, that trickle puffs radio knots and arcs. In bigger ellipticals, quiet jets inflate vast, ghostly cavities. Those cavities heat halo gas, stopping runaway cooling catastrophes. A weak whisper can cancel a million small cooling losses. Meanwhile, stars still orbit and clouds still drift inward. Each pass rearranges orbits, priming the next brighter snack. so the center dozes, yet keeps the thermostat set. Takeaway: faint feeding stabilizes galaxies between their dramatic quasar outbursts. Pull the camera back until galaxies look like lanterns. They hang on the cosmic web, a lattice of filaments. It matters because these roads decide who meets whom. Gravity draws matter along strands, piling it into crossroads. Dark matter halos grow as streams pour in steadily. Gas follows the scaffolding, cooling as densities slowly increase. Velocities are gentle by cosmic standards, hundreds of kilometers per second. Flows reverse rarely unless feedback kicks material back uphill. Mergers happen at the nodes, timed by this quiet drift. Between events, galaxies commute, carrying companions and long tidal tails. A typical filament spans tens of millions of light-years. Cross-sections can be a few million light-years thick. Within them, dwarf galaxies surf currents toward larger neighbors. Their orbits process slowly, shaped by nearby mass concentrations. Cold streams can even thread deep into massive halos. That keeps disks fed when halos should be too hot. Weak lensing maps outline these highways with subtle shape distortions. Simulations overlay the same pattern, now animated in slow time, so the web is not background wallpaper, it is traffic. Bottom line, the web stage manages every later dramatic entrance. Inside the darkest clouds, chemistry whispers across icy dust. Those dust grains are tiny labs, surfaces where atoms meet. Care because these reactions preload newborn systems with life's ingredients. Atoms land on a grain, stick weakly, and shuffle around. They find partners, snap together, then hop back into gas. Hydrogen pairs first, making H2O, the master coolant of clouds. Oxygen grabs hydrogen, forming water ice mantles on grains. Carbon and oxygen join, birthing carbon monoxide and methanol too. Cosmic rays and UV photons break bonds, then drive new bonds. The chemistry loops quietly, cycling for 100,000 years. Temperatures hover near 10 Kelvin, barely above absolute zero. Densities reach around 10,000 particles per cubic centimeter. When a star switches on, ices desorb and perfume space. Radio telescopes catch these scents as sharp spectral lines. Example in real terms, ALMA sees methanol around infant stars. It also maps water vapor plumes in warm inner zones. Comets later trap this cargo and courier it to planets. Earth's oceans may include shipments from such deep freeze factories. So the lab work runs in darkness, setting future menus. What to remember: molecules assemble long before first light arrives. Far from nebulae, mature systems do quiet housekeeping. Between impacts, gravity and sunlight still reshape small bodies. You should care because orbits today decide climates tomorrow. Planets tug each other, trading momentum in slow, resonant dances. Asteroids drift as sunlight warms them unevenly, the Yarkovsky effect. Dust grinds down in belts, forming zodiacal clouds and rings. Comets leak gas, then split, receding meteoroid streams again. Migration still happens, but at glacial, whispering speeds now. Occasional close passes shuffle eccentricities by tiny, permanent steps. Over millions of years, those steps reorganize entire architectures. Delivery services keep running, moving water and organics inward. Earth still collects about 40,000 tons of dust yearly. Moons feel tides, flexing and warming subsurface oceans gently. Resonances lock in stability, like Jupiter's Trojans in step. Some bodies escape, leaving gaps that shift resonances again. Space weather reddens surfaces and builds fragile regolith blankets. Spectrometers read those blankets, revealing histories of sunlight and fire. The quiet phases write most chapters, while impacts add exclamation. So even serene skies hide machinery grinding beneath silence. Bottom line, small nudges sculpt worlds between their rare catastrophes. Even emptiness has activity, a choir humming beneath noise. Space is filled with backgrounds, gentle fields that never sleep. This matters because they set baselines for everything else. Photons from the Big Bang still bathe us at 2.73 Kelvin. Neutrinos drift colder, near 1.95 Kelvin, ghosting through planets. Gravitational waves ripple spacetime, with periods of years to hours. Dark energy stretches scales, making distant clocks tick apart faster. What happens mechanically is simple expansion. Wavelengths grow with space. As space grows, light reddens and backgrounds cool very slowly. Galaxies fall together locally, while the fabric itself spreads gently. Pulsar timing arrays now hear a nanohertz gravitational murmur. The signal looks like a shared sway in spinning lighthouses. CMB maps show tiny hot and cold spots, fossil weather. Those spots set the seeds for later galaxies and clusters. Laboratories underground count neutrinos from reactors, inferring cosmic backgrounds indirectly. Spacecraft radiometers confirm the microwave bath with exquisite precision. Each background is quiet individually, but together they steer history. Heat leaks downhill, structure rises uphill, while light keeps stretching. Time smooths sharp edges, turning booms into gentle background chords. One sentence recap: the floor hum controls the room's acoustics. That floor sets pace, scale, and the direction of change. So the silence is structured and always at work. We started by asking what the universe is doing now. Answer: it is lining up the dominoes between big bangs. From dusty alleys to halos, quiet work runs the show. From whispering black holes to slow rolling filaments, preparation never stops. From ice chemistry to drifting asteroids, details rewrite future headlines. That is the loop we closed. Stillness is setup, not pause. If this changed how you picture the quiet, stay curious. I make more deep dives like this, gentle and clear. Tap subscribe and catch the next one when it drops. Until then, go outside tonight and enjoy the patient sky. Remember, between booms, the cosmos is busy becoming itself. See you in the next chapter, under the same hum.